This is digital systems. For this question, I'd say it's relatively interesting because we're asked to write C programs rather than assembly, which is kind of weird, but I think it's pretty good. So in this question, we're asked, you're designing a household automation system with a display that can show animated reports from various modules, such as this. The display can also be used for urgent reports. Software to drive the system is also in place. You'll need to provide a mechanism to ensure that the display is not used by more than one client process at a time. Software runs under an operating system that provides message passing as a synchronization mechanism. You should express your answer to this question by giving an outline of code for the specified processes. You do not need to write out the implementation of common data structure as long as you specify them. In part A, we're asked to design a server process that is able to accept request messages from client processes and replies with a grant message that when it is safe for clients to use the display. Later, the client will send a release message to indicate that animation is finished. You may assume that clients will follow this protocol and do not try to use the display without requesting and receiving permission first, or fail when to release when they're finished. So basically, we want to create this server. So over here, this is sort of the code. I'm going to walk through it. So over here, we have this server process. We're going to use a queue, obviously, so that's first in, first out to ensure fairness. And then let me see. This color doesn't work out very well, but I guess, yeah, this one works pretty well. So I'm going to walk through it. So here we have, we're just going to create a function called display server, pretty straightforward. Then we have a data structure, which we call queue. We're going to call it pending requests. And then we have a flag that just tells us if the display is busy or not. And we initialize it with false. Next, we just keep track of the current user. We're just going to call it process ID. Process ID is current user. And then we have a message, and then we start our loop. We're just going to call while true, so we're in this infinite loop. And then over here, technically the system would block it because it would just sleep and then just switch to another program to run until it receives something. So we're going to receive any end message. So basically we would receive any kind of message that comes, we would receive it and we wouldn't create a copy of it, we would just reference it. And then in here, what we do is we kind of just break it down into two cases. If the message dot type is equal to request, or if it was released, right? Um, if it was a request, then it's basically starting the animation. So we will check that first, the display is not busy. If it's free, not busy, then it means that it's free. So we're going to grant it access. So we're going to first initialize it to true because we're now using it, right? And then we're going to update the current user to be the message.sender. And then we're going to send the current user and then grant them the access. Otherwise, what we would do is in the case that it's busy, then we would just enqueue it. So we're going to add it to the queue by enqueue, and then inside pending request, we're going to put in the ID of the client. And then if it was a release statement, that means that we're done, right? So that means that this one is just checking that it's the current user. It's definitely a good thing to do, but it's not needed. And then we just check if the pending request, if there's anything left in the queue. If there is, we're going to take the current user and dequeue it from the queue. And then we're going to send and get them the access to use the display. Otherwise, we're just going to say display busy equals false. That means that right now it's in the idle state. So yeah, this would be the display server. Think it's pretty good and clear. And then in part B, we have, in order to allow urgent reports to be displayed sooner, request messages are now given in a parameter that is 0 for ordinary messages and 1 for urgent. So basically now there's this priority system in place. And the server processes give priority to urgent requests. Design an enhanced server process that implements this interface. So this would just be the similar code from before, except we just have to keep track of two queues. One queue is for the ordinary, one is for the urgent, and then we just check if it was urgent or ordinary, and then prioritize the urgent over the ordinary for sure. So yeah, we have the two queues. This is the new queue that we added, the urgent queue. And then the same thing as before, we have this display busy, process ID of the current user, message, nothing has changed from here. The while loop is still the same. We're going to try to receive a message, check the type of the message, either release or request. In the case that's request, again, check if it is busy or not. If it's free, then we're going to initialize it to true. Just going to send whatever the thing that is. We don't care what it is. Right now, that's the only thing on going on right now. So we're just going to grant the access. So up to this point, nothing has changed. In the else statement, when the thing is busy, we would want to sort it into which queue we want to add it to, right? If it's the priority is equal to 1, so it's urgent, we're going to enqueue it to the urgent queue. Otherwise, we're going to give it to the ordinary queue. So it's really straightforward. There's basically, this is the only kind of logic that has changed. And yeah, this extra queue that was added is something new as well. And then in the else if, basically, we would check that it's released. And then what we would do is, in the case that we want there is something going on, we would want to first check the urgent queue, right? When we're done, we want to first check the urgent queue and see if there's anything. If there is something, then we would just dequeue it and send the first element off and grant the access. Otherwise, if there's nothing in the urgent, then we check the ordinary to see what if there's anything. And then otherwise, we would keep the display busy as false. So basically, the only thing that was added here would just be this urgent thing that was checked before the ordinary. So that's the only part that got changed. So that is pretty, I'd say 10 marks is quite a lot to allocate for this. I'd say like definitely this 6 marks should be worth 10 and this should be worth at most like 6 or 7 at most. Because I feel like this is just building off of A. If you got A, then B would just be a few lines worth of change of code. And then in part C, we have, in order to avoid the difficulty of implementing a queue of processes that are waiting for a post, a report, your colleague suggests using a stack instead. Would this be a good idea, or might it introduce problems that make behavior unacceptable? Justify your answer. I mean, like the minute the queue ensures that it's a first in, first out sort of process. If you're talking about a stack, it's first in, last out, right? That's not going to play out very well, especially because over here, um, in the case that let's say um, we had an ordinary process and then we put it in and it was busy, so we had to put it in a queue. And the next week we were very busy and we kept on getting stuff added to the queue faster than we can process it. So people use up the display for a longer period of time. So then whatever that was added into the stack first would have meant that it would just stay there in that idle state in that stack forever while we're processing other things that arrive eventually. So then that means that it's definitely not good because it's just stored there and not processed. And it's also unfair because it's not sorted in chronological order. So the people who come at the right time could be processed first, which would not be good for us. So yeah, the idea is that it's not good because there is the case that if it's busy and there's more incoming requests, a stack may never be granted access. And yeah, also the unfairness of the chronological order is not in that order if it was a stack. So yeah, that ends off this question.